Before going into the concept of group and its conditions, let's try to talk about identity element for any binary operation star. We know that identity element for any set under a specific operation, just like in the usual addition and set of real numbers, and even the usual multiplication, we have specific identity elements for them. It's actually a certain element that in the same set that when we pick any of other elements on that set and operated with that certain element, it doesn't change the value of the given element. Hence, it's called identity element for the set under a given operation. So similarly here, let's talk about the definition of the identity element. Let's say, let S, okay, this operation, and then star, be a binary structure. This is the other way of stating that the operation star is a binary operation under on S, okay, on set S, okay. An element E, okay, this is what we usually label for identity element. Element E of, or let's say, element of our set S is an identity element for the star operation under the same set if we can actually satisfy the given equation that when we operate the identity element to any element, let's say R, okay, or let's just say since it's S, small letter s, it's just equal to S star E, and it's just equal to S for all element of S which are small letter s. The point here is, if we can see a certain element is still an element of S, such that this operation is similar to this. Of course, the operation or the binary operation depends on what type of it's how would we define the said star. If the resulting value for this is just S itself, then E is an identity element. As mentioned earlier, common example for this is the element of 1. Okay, let's not start with 1. Okay, let's start with the usual addition. In the usual addition, in a set of real numbers, okay, the identity element for that is 0, because whatever value you pick or whatever real number you will pick, and then you're going to add it to our 0, it will just be the value itself. So for example, 1 plus 0 is just 1, square root of 3 plus 0 is just square root of 3, so it just retains its value. Okay, the same thing for usual multiplication in R. I'm just denoting it with dot. Our identity element is 1, because whatever value in the set of real numbers you're going to multiply by 1, it's the value itself. So say for example, 26 times 1 is just 26. Let's say 1/3 times 1 is just 1/3. So again, it doesn't change the value. So basically, if we will be talking about groups later on, because identity element is one of its conditions, then it should the certain group to be called a group, or a certain set to be called a group, must exhibit or must contain its identity element. Because if identity element is not present, and take note, it's an element of the same set, then we cannot call it call a set a group. So we will be having an example or further more detailed discussion with regards to the definition of the group and some of its examples. Just this point here is that there exists an identity element for a star if it follows this condition. Thank you very much for watching.